Hello friends, welcome to my channel Easy Education. Be smart and fresh. Let us start here the today's subject. Let us learn the Newton's laws of motions and in a practical way with the help of some simple examples I am going to show you the laws of motions. These laws of motions are not just limited to your physics textbook, but they are happen all around us in our everyday lives. And after we do three laws of motions, we will finish the top three questions on this topic. I am sure at the end of this video, concept will be super clear to you. Now, before we start, we get quick recap these three laws of motion. Here are the statements of the first law, second law, and third law of motion. Now I am going to show you some simple everyday examples and you try to decide which law is applicable. Is it Newton's first law, second law, or third law of motion? These types of questions are quite popular in the test, and we will give you an examples and ask you to explain based on one of these laws. So get ready to put on your thinking glasses. Are you ready? Let us start. I am sure you have heard it. It is important to get fastened to your seat belt when you are in car. Now let us see which law is based on. Are you ready? Let us go for a drive. Now the person is driving. Suddenly he applies the brakes. Did you see what happened? He was thrown forward. In another case, the lady is driving the car and applied the brakes suddenly. She would have injured seriously, but due to seat belt, she could kept safe easily. So, which law of motion applies to this situation? What do you think? The correct answer is the Newton's first law of motion. This law deals with the inertia of the rest and the inertia of the motion. Let us see which type of inertia applies here. When the car is moving, the drivers are also in motion. Now when the brakes are applied, car comes to stop. But the drivers are in motion due to inertia of motion. So they get thrown forward due to the inertia of motion. So it is Newton's first law of motion that talks about the inertia which applies to this situation. So what is the moral of this story? You always be safe and fasten your seat belt. Now I am going to get off now and go for a walk. Let us see the simple example. So while walking, which law of motion applies here? That is right. That is Newton's third law. Now let us take a closer look. When you are walking, your feet are pushing the ground. When you are walking, your feet are applying the backward force on the ground. Ground in turn applies forward force on your feet, pushing us forward and making us to move. Can you see the action-reaction pair? Action is our force on the ground and the reaction is the force of the ground on us. The two are equal and opposite. So it is Newton's third law of motion. Every action has equal and opposite reaction. And this law explains how we walk. Let us see. You are playing the game like cricket or baseball. Here I have a cricket ball with me. The coaches teach you to take the catch like this, with your hands moving down. But if you take the catch like this, out. Since the ball is quickly heavy, it hurts your fingers or it can bounce your hands, or if you take the catch like this, it doesn't hurt your hand. Why is it that? Which law will help us to answer this question? To analyze, let us consider some numbers here. The mass of this cricket ball is 150 gram. Let us say the speed of the ball which hits my hand before the catch is 10 meters per second. Let us see the speed of the ball which hits my hand before catch is 10 meters per second. So the initial velocity is 10 meters per second. Now what is the final velocity after the catch? That is right. It is 0 meter per second. Now let us say as I didn't take this catch in the correct way. So the ball comes to sudden stop, say in 0.03 seconds. So how do you calculate the force in this case? By Newton's second law of motion. Force equals the rate of change of momentum. The formula is F is equal to mass into acceleration, which is force is equal to mass into final velocity minus initial velocity divided by time. Now plugging in the values, we get the force as minus 50 Newton. There is negative sign because it is the retarding force. But we will ignore the sign. So my hands feel the force as 50 Newton during the catch. Now let us catch the ball in correct way. As you can see, by moving my hands down, by increasing the time of the catch. As you can see, by moving my hands down, by increasing the time of the catch. So let us say that time is 1 second. Other numbers remaining the same. What is the force now? Let us use the formula. F is equal to ma. Plugging in the values, we get the force of minus 1.5 Newton. So that is the retarding force of 1.5 Newton. It is approximately 33 times lesser the previous value. Now why is that? Because in this case the time of the catch is increased. Now the time is in the denominator of the formula. So the rate of change of momentum is lesser. As a result, my hand experiences a smaller force. So as you can see, Newton's second law of motion helps us to explain this example. Now let us play the tennis. While playing tennis, you want to hit the ball and in a direction that makes it hard to get other players to play. So how do you do that? By hitting it like this. When we want to hit the ball hard and in a direction we want it to go, a greater force causes a greater change of momentum in the ball and makes it go faster. So the ball moves in the direction that we hit it in. So, which law of motion tells us this? That is right. It is second law of motion which states that rate of change of linear momentum is directly proportional to the applied force and it takes place in the direction of the force. So if you hit the ball with the greater force, the ball will go faster. There will be greater change of momentum in the ball and the change of momentum takes place in the direction of the force. You might have seen this magic trick before. Here, see, here I have kept one glass of water on this table. Now I am covering it with a cloth and keeping a blade on it. Now I am suddenly pulling the cloth. As I am pulling the cloth, the blade kept on it should come along with the cloth. I am not the magician. So please wish me luck. Let us try. Ready? 1, 2, 3. Oh, I am happy. It works now. The blade didn't come out along with the cloth. The blade remains as it is. Only cloth gets removed. But due to the gravity, the blade falls down into the glass water. Why it is so? It is due to the inertia of rest of the blade. The blade doesn't move suddenly along with the cloth. Now let us take action replay and see which Newton's law is behind this magic trick. As you saw that when I pull the cloth really quickly, the blade don't come out. Inertia is the laziness of the body. Now there are two types of inertia. Inertia of rest and inertia of motion. Now which one do you think is applicable in this case? That is right. It is the things on the cloth when they are at rest and they want to remain at rest. So when I pull the cloth really quickly, that they resist that momentary force, and that is how the blade don't come along with the cloth. So the Newton's first law regarding inertia explains this example. Let us see what we can learn from this balloon here. Children are playing with the balloon and going to release their balloon. You will see there it moves around on its own. So are you ready? Let us start. Now let us take a look at this action replay. When they release it, the balloon pushes out the air inside it, with the force making it move forward. Now, are those forces equal and opposite? Yes. So, which law we are talking about? That is right. It is Newton's third law of motion. And the same law explains how rocket works. The rocket exerts the forces on the gases backwards, and gases exert force in equal and opposite directions, making the rocket forward. Just like this balloon. Let us wind up here and summarize the gist. So, here are the 6 simple everyday examples we'll look at for Newton's laws of motions. Are you ready to take the top 3 questions on this topic? Question number 1. Do action and reaction forces act on the same body or different bodies? Answer. Action and reaction forces act on the same body. Question number 2. When a wet piece of cloth is shaken, the water droplets fall off. Which law of motion explains this? Newton's first law of inertia. Question number 3. Explain swimming based on one of the laws of motion. For every action, there is equal and opposite reaction. This is the Newton's third law of reaction. I hope you have enjoyed watching this video. I will encourage you to look around and see if you can find Newton's laws of motion in your everyday life. Let us know what examples you experience by putting in the comments below. Inspired by Sir Isaac Newton, I am going to tell you to leave your inertia at rest. Take quick action and apply your force to subscribe on the button. And my way of action will be thanks for subscribing to my channel. Thank you very much.